Hi, my name is Trevor Hagelin, and I'm going to be talking about my senior project, which is involving compression molding of a carbon fiber wheel center, which will be used in the Formula SAE electric car this next academic year. Basically, I've been performing a lot of the work so far in collaboration with Alex DeCarli, another student in manufacturing engineering, and we have a technical advisor, Dan Waldorf, who has been helping us along the way, as well as our industry advisor, Ken Gamble of Quattro Composites, who has been sponsoring us along this process. So we want to say thank you to both of those advisors for helping us and aiding us along in this process. So some of the things I'm going to be talking about in this presentation are the background of our project itself, the problem associated with what is going to need to be done, some of the things I've discovered during my research on the subject, and the material that we'll be using that is given to us by Quattro Composites, the process that we'll be using along with that material, and a look ahead for what's to come in the future and what we're excited about doing. So background on a little bit of the composite market in the automotive industry. Typically, composites are used as a aesthetic pleaser for most people, also as a way to reduce weight on their vehicle. A lot of people enjoy the look of carbon fiber composites on automotive vehicles or automobiles, and they also enjoy the weight reduction that it gives them to increase their performance. Typically, the composites that are used have different structural elements than carbon fiber. Carbon fiber is up and coming in the automotive industry right now. It's expanding at a large rate, and it's moving into different areas within the structure of the automobile. And what we're going to be focusing on is the wheel center of the Formula car, but by extension, if it could be used commercially. And wheel centers today are typically used or typically made up of aluminum alloys or magnesium alloys or steel, and aren't normally done with composites at the moment. There have been some initial product out there using carbon fiber for wheel centers, but typically they're laid up. They're not done through compression molding, which is what this project will be doing. So there's a big opportunity for carbon fiber in the wheel center industry, especially for the racing aspect of it. Not a lot of race cars use composites in that way, and typically they use aluminum, and they're looking for ways to reduce their car weights even more, so we'll be trying to do that. The problem that we have is to design and fabricate a reproducible product that has quality that can be reproduced many times, or a high level of quality. And in order to do that, I need to use my knowledge of manufacturing processes as well as manufacturing tools in order to create the best, highest quality product that can be recurring, and I can make multiples of them and have the same quality repeat itself, which is what we're going for. And in order to do that, we need to design and fabricate a working compression mold, which can be used for compression molding, and with that comes along the lines of mold design, proper mold design. Next would be to design a fixture for secondary machining, which involves different tooling and different holding and locating principles learned in manufacturing engineering. And lastly, after that, we need to determine what the standard is for a quality product and what we're looking for in terms of defects or irregularities, and what classifies a quality product in this process. Some of the research I did showed that magnesium is most used for lightweight wheels. It's also the most expensive thing to use for lightweight wheels. And if carbon fiber wheel centers were to strike it, then they would take over this industry of the lightest wheels you can buy. And composites have been used, especially carbon fiber composites, have been used in a lot of different industries throughout the years, such as spacecraft, jet engines, wind energy, even marine applications. Carbon fiber composites are working their way up and being used more and more. But only about 10% of the market share uses carbon fiber as their reinforcing agent. The most common would be the most common fibers aren't typically carbon fiber. They I'm drawing a blank on them, but typically only 10% of the market share is carbon fiber. And along that, you have your reinforcing agent, and then you also have your strengthening agent or your matrix material, which is typically a thermoset or thermoplastic resin. And a lot of my research dealt primarily on the differences between these two, and the differences in their cure time, and the differences in whether they can be reworked or their strength and stiffness. And thermoset ends up being one of the more difficult to work with, but is definitely yields a stronger and stiffer part overall. The process I'll be doing involves compression molding, and the compression molding apparatus we have on campus that we'll be using is a heated press that has a 50-ton maximum of pressure that it can generate, and that's really good, or that force that it can generate. So we're going to be using that press, which also has heated platens that will heat our mold to a proper temperature and encourage the material that we put into the mold to flow into its different areas, so that charged material will flow and be able to fill in each part of the mold and have the mold pressure help distribute that material evenly. After that compression is initially finished, it's going to remain in that state for 5 minutes approximately in order to cure and solidify the resin. The material that we'll be using is sheet molding compound, or SMC for short. This material has been donated to us from Quattro Composites by Ken Gamble, and we have it on hand and we're ready to use it once our mold is complete. Sheet molding compound, when it's done or when it's cured, has a high strength to weight ratio. So it is comparable to aluminum in terms of strength and stiffness, but it is about half the density. And in sheet molding compound, there are various catalysts and cure catalysts and compounds and different resins used in order to give these qualities to sheet molding compound. So it's a pre-cured product that needs to be refrigerated and used in compression molding. It has a high resistance to moisture absorption and fatigue, which makes it a very good candidate for wheel centers, and can be post-machined without reducing the integrity of the wheel center, actually, because it has high stress concentrations already within the part due to the discontinuous chopped fibers that are about 25 to 50 millimeters long, and that gives the strength comparable to aluminum, but also doesn't reduce integrity when it is machined, which is good. So this is suitable for aluminum replacement and use in a wheel center. So as far as what's next in the project would be to produce and complete the finished machined mold, which the part is shown here. We are going to machine the mold. The mold design is already done. It hasn't been included in this presentation, but it's pending approval, and then once we are in possession of the materials, we can make the mold. After that, we'll have initial runs of the wheel center using the SMC material. Then we will design the fixture and do any post-drilling operations, and finally perform cost analysis in order to determine the cost of this part according to the process, the material, the labor that has been putting into it, and analyze the triple bottom line as well. So those are the things that we're looking forward to in the project. That'll be done in the next few months. We're excited about it, and I was happy to share my progress with you so far. Thank you.